Hello, welcome to this fresh and new 7th episode of the Barebones for the Practical PM series. I am releasing a video after a long gap, but like earlier, for this series, we will continue to pick up concepts that are important to product managers, cut through the fluff, and get to the essence of it. Today, we are going to discuss product data analysis. If you recall our episode on analytics, there are many sources of data that you can use for analytics. Native product data is one of them, but there can also be events data that you generate specifically for analytics. There can be data from supporting systems like help desk. There can even be external data. In this episode, we are specifically going to focus on the data that comes from the core product, that is native product data. If your product is an e-commerce platform, then this is the data that your product has by virtue of enabling the platform, where there would be buyers, products, sellers, where purchases will be carried out, and where the status of the orders and the products will be recorded. Please note that this episode assumes that you understand the basics of SQL or SQL, however you pronounce it. Why does native product data need special attention? Because this is one source of data that is super critical to analytics, but which is not designed for analytics. It is designed for the robustness and performance of the actual product. What does this mean? Consider a very typical analytical task for an e-commerce platform. You want to find out which categories of products are popular in different cities in India. Now, you would want to have the relevant data in a table like this, where against each order ID, you have the information of the product including its category as well as shipping including the city and state. But in reality, the product data tables will look something like this. I will leave you to stare at the screen for a moment. There is an order table, a suborder table, a suborder product table, address table, location table, user table, product table, category table, product category mapping table. Now take a deep breath, relax, and then ask, why is the data like this? So scattered and spread out? Do the developers hate product analysts? The answer is no. Mostly, developers don't care about product analysts because their job is to deliver a robust product, not the data all prepped up for analytics. Still, why such scattered data? Because one principle of database design for creating robust products is normalization of data. Intuitively, this means that you do not want to have the same data in two places. If there are two sources of the same data, if the same data has to be put in and updated in two tables, sooner or later it will become inconsistent and result in all sorts of errors and bugs. Hence, in most products, you will have the data looking scattered across multiple tables. But it is not scattered, it is just normalized. For you as an analyst, this means that instead of running a simple Excel operation or simple SQL query to get your answer to popular categories in different cities, you will probably have to run an SQL query with 100 join statements. This e-commerce platform, it seems like, allows a single order to have multiple shipping addresses for different items. Hence, the addresses are stored at suborder level. A suborder in turn may have multiple product IDs, and for each of those there would be a row in suborder product table. So to get the products, you need to start with suborder product table. But to get the address each product was shipped to, you need to refer to suborder table and hence join with that. You will get address ID from there, but to get the details of the address, you will need to join it to the address table. Address table also gives only the city ID. To get the city name, you will in turn need to join it to the location table. On the other side, you have started with product, but you need categories in your report. So you need to join that to product category mapping table. And that will also give category ID only. So to get the category name, you will need to join it to the category table. So often you will find that creating reports and getting information from native product data is technically a little bit more complex than analyzing something like market data that you may get in much more straightforward tables. Even if you manage to write these complex queries with multiple joins, you may have to learn to optimize it, because with too many joins, queries may become too heavy to run in reasonable time. Your analytics stack may even have a limit on how much resource your queries can use. So, if there are tables that you find yourself joining repeatedly in almost every report that needs them, for example, the order, suborder, product, category, and user tables may be getting joined very often, then you can work with data engineers or whosoever is managing the data warehouse to create views out of these. Views for practical purposes are derived tables created by joining multiple tables. These views can be used like a single table which has all the data already present. Views, of course, mean that the data is no longer normalized, but that is fine because you're not changing anything in the product. If normalization of data is a holy grail for good product architecture, denormalization is the base sauce for any analytics recipe. So that's about dealing with normalized native product data. There are some more quirks of this data that you should be aware of. Some of them arise from the practice that unless absolutely required by law, data is almost never deleted from production databases. A user cancelled their account, the corresponding row in user or subscription table will not be deleted. There will most likely be a column that indicates that this account is cancelled. A blog post was made by mistake on your blogging product and the user later deleted it, there is still likely to be a row for it with only a column indicating that it has been deleted. So with pretty much any table you use, do familiarize yourself with what are the valid rows you should be considering. In your e-commerce platform, probably for most of your analysis, you would be focusing on orders that were not cancelled, but every once in a while you may need to analyze cancelled orders as well. Sometimes, even just for determining which rows are valid in a table, you may need to join it with another table. For example, consider a SaaS product where the analysis you are doing, for that you may have to leave out all the transactions from the users who are no longer subscribed. Now, the subscription status may be available only in user table or a separate user subscription mapping table. Any transaction tables you are using may need to be joined with it to filter out the transactions from the users who have cancelled their subscriptions. At times, test, dummy or internal data may need to be filtered out for analysis. Sometimes there may be a column in a table indicating that the data is real or not. At other times, it may need to be inferred from another property. For example, to remove all internal orders from analysis, you may need to filter out all the orders placed by users with company's official email IDs. If such filtering is almost always required and you find yourself joining tables just to get it done, then this is also something for which you may want to get views created. Sometimes you also have to put in efforts into understanding the modeling of data, which may be non-obvious except to the developers. For example, the category table that we saw in our e-commerce example has 3 columns: category ID, category name, and category parent ID. This may look a little non-obvious. Typically, there are categories and subcategories and you might expect that information to be available upfront. But if the levels of nesting can be many more, especially if the number of levels required is unknown upfront, then that kind of design breaks down pretty fast. So this kind of design, which we saw in our database, would be pretty common, where you just have a column for category parent ID. Here, the top level categories will have category parent ID as null, and all other lower level categories will have their parent ID specified referring to another category entry in the same table. For example, if you have a category tree like this, where there are books and there are apparels and then there are multiple levels of categories and subcategories within these two top level categories, then you will see rows in the category table like these. For top level categories, parent IDs will be null. Then you will see entries for next level of categories. For example, the trade category will have category parent ID as C001, which is books category, because trade is a subcategory of books. Fiction in turn will have trade as the category parent ID. Let's fill this table with some categories under academic. Parent category for academic is C001 books. Parent category for school, college and university and STEM is in turn C010, that is academic. So the table looks like this. This way, infinite nesting of categories is possible. Now let us see the category graduation. It comes under college and university as well as STEM. We can model it as a single category and have two rows for two parents. For one row, we will have C012 as parent, which is college and university. And the second row will have C013 as parent, which is STEM. Strictly speaking, these two rows to model two parents is not a normalized structure. If such modeling were required, you will probably have one more table in the mix. But I will not confuse you more with normalization here. The main point is made that if you do need information on different levels of categories, you will have to understand the logic of this table and traverse it accordingly. So let us move on. When dealing with the categories of products, you will also need to understand the logic of product category mapping. Is the product mapping typically done at the lowest level category and the product's membership of higher level of categories implied? Or does the product category mapping contain all categories a product belongs to, even if one of them is the parent category of another? For example, if there is a book in fiction category, what does the product category mapping look like? Is there a single row like this where P001 product ID is mapped to C004 category ID, that is fiction? And since we know that parent of fiction is trade and parent of trade is books, then P001 is assumed to belong to trade and books category as well. Or does the product category mapping table store mapping for all possible categories including parents, like this, where P001 is mapped to C004 fiction but also to the categories for trade and books separately? With either of those kinds of mapping, you should be able to extract the information you want. So the exact mapping does not matter, but you will need to know what kind of mapping there is. So overall, to do good product analytics with native product data, you need to understand the architecture of the product a bit. You need to know which tables have the data, learn how the rows are to be filtered to get the valid ones for your analysis, and work with or around the normalization of data. That is all. Hope this was useful. Are there any specific issues you have faced while dealing with native product data? If so, do leave a comment for the community to learn from. Thank you very much.